Hey everybody, this is Gregory from Dapp University. So welcome back to this multi-part tutorial series where I'm showing you how to build, a real-world crowd sale where you can raise real funds and a real ICO on the main Ethereum network. In the last video, I showed you how to create a refundable crowd sale with a goal. And in this video, I'm going to show you how to create a crowd sale with multiple stages. So we're going to have a pre-ICO stage and a main ICO phase. So check out that previous video if you haven't already, and be sure to subscribe to the channel to see the next videos in the playlist when they come out. This episode is presented by QuickNode, the fastest and easiest way to run your own Ethereum node. QuickNode lets you run a personal cloud-based Ethereum node in a flash without having to download any blockchain data or keep it in sync. Sign up at quicknode.io today to start running your own Ethereum node in no time. Alright, so in this video, we're going to continue building on top of this Dapp token crowd sale smart contract. And for now, I think we've actually imported all of the OpenZeppelin dependencies that we need for the different types of crowd sales. We have a crowd sale, a minted crowd sale, capped crowd sale, timed, whitelisted, and refundable. That's all quite a mouthful, but that gives us most of the behavior we need. So I'm going to actually continue building on top of this. And what I'm going to do is actually create multiple phases for this crowd sale. So what I'm going to do is have I'm going to have a pre-ICO stage, and I'm going to have a ICO stage. So we'll say crowd sale stages, and we'll have a pre-ICO, and we'll have, well, I'll say pre, and we'll have ICO phases. Okay. So we need a way to keep track of these, and I'm going to use something called an enum in Solidity. We could do that like this. We say enum crowd sale stage, right? And we'll actually make this like this. Say, and so what this is going to give us a basically, if you're familiar with an enum from another programming language, it's going to give us like something that we can basically pass an integer value to, and it's going to return whatever values inside of here that corresponds to that. So we'll say like pre-ICO, and we'll say ICO. Okay. And what we're going to do is set a default stage here. So whenever we deploy this smart contract, we're actually going to set a crowd sale stage. Say default to presale stage. Oops. And what I'm going to do is basically be able to read from this enum. So we'll be able to say like, crowd sale stage. And, we'll declare this public, right? So this will give us a way to read out of the enum, like, which of these currently is selected. It's basically like, this enum is going to keep track of one of these two options, and, one of these is going to be kind of currently selected in the state. So whenever we set this value, it's going to be one of these two. We can set its default as crowd sale stage dot pre-ICO. All right, and that's actually going to set the default. So we can do that. All right, now let's see here. We have a way to track both of the stages in the ICO, and we have a way to store it, and we have a way to read the value for whatever the current stage is. So we can try to test for this just to make sure that this works. We can say, let's go ahead and add some examples right here. We'll say describe, let's do it after refundable crowd sale. Let's do it here. So describe refundable crowd sale. No, sorry, crowd sale stages. And we'll pass in a function. Right? And I'll say let's just use this test. We'll say it starts in pre-ICO. Okay. So basically, we'll say stage equals await this.crowdsale.stage, which is what we just declared here. We'll say stage should be big number equal to this.pre-ICO stage. So we need to define this pre-ICO stage, and we can do that up here. Let's make a new section. We'll call this ICO stages. We'll say pre-ICO stages 0, and then we'll say ICO stage is equal to 1. All right, we'll save that. So I can run this test. Say truffle test, and then Dapp crowd sale. All right, it passes. So this is returning that correctly. So it's returning 1 or 0, sorry, which we expect. That's the pre-ICO stage, and that's what we're doing here. So now what we want to do is actually create a way for an admin, the owner of this crowd sale, to update the stage. So we'll do that like this. Below get user contributions, we'll say function set crowd sale stage, and we'll say uint stage. And this will be public. We'll say that only the owner can do this. And I'll just pass this body here. So now I'll say basically if, so basically we'll say like, pass 0 or 1 here, and whatever this corresponds to, it'll update the stage out of this enum, and it'll set this value here. So what I'll say is like if, we'll course this to an unsigned integer, uint crowd sale stage, oops, sorry, having trouble with my autocomplete, crowd sale stage at pre-ICO is equal to this stage that gets passed in. Then I will say stage equals crowd sale stage pre-ICO. We'll actually update that. So stage here is getting updated. And if it's not, we'll say uint, say crowd sale stage ICO equals stage. Then we'll update the stage to ICO. All right. So that's pretty simple. And what I'll do is paste in some notes here, just like we did in the other functions. We'll say this allows an admin to update the crowd sale stage, and we'll pass in a description for the parameter. It's going to be this stage here. All right. And now what I want to do is write a test for this to say that an admin can update the stage. So I'm going to say it allows admin to update the stage. I'll say, let's see, we'll pass this an async function. All right, I'll move this over. So let's say await this.crowd sale, set crowd sale stage. And let's set it to this.ICO stage. All right, we define that here. That's 1. All right. And I'm going to pass in from field, so from the account that deployed the crowd sale, which is going to be the administrator. So I'll say const stage equals await this dot crowd sale stage, and let's say a stage should be big number equal this dot ICO stage. All right, save that and run the test. All right, that passed. So let's also test to make sure that someone who's a non-admin can't update the stage. So I'll just paste that in like this. Let's just go ahead and make this one column. So it prevents a non-admin from updating the stage. And this is going to be this crowd sale stage, this ICO stage from investor one. We don't want investor one to be able to update the stage and do whatever he wants. We only want an admin to do this. So we'll say this should be rejected with EVM revert. We'll test that. All right, that passes. Yeah, we have a way to successfully update the crowd sale stages. Now, there's a couple different pieces of behavior I want to add here. The first thing is whenever we're in each of these stages, I want to have a different token purchase rate. So basically, like if I send 1 Ether in pre-ICO stage, I want it to be able to buy more tokens than when I send in the crowd sale stage or the ICO stage. So like in the public phase, like it's going to be more expensive to buy tokens in the pre-sale stage. So you're effectively getting a discount here. So I'm actually going to change the rate whenever this crowd sale stage is set. So if you remember, like when we deployed the smart contract, we passed in a rate, and we said that this was 500 from our test. I'll show you. We said, rate is equal to 500. So that means basically you're getting 500 tokens for 1 Ether. So we'll say that that's the pre-ICO rate, and in the public sales, we'll say that you get 250 tokens per Ether. So basically what's going to happen is when we set the crowd sale stage, we want to update this rate that's stored in a state variable. It's coming from crowd sale. I'll show you. It's coming from here, stored in a state variable. So we'll do that like this. We'll say if stage equal to crowd sale stage dot pre-ICO, and we're just going to hard code these rates in here for now. I'll say rate equals 500. That's what we passed into the constructor. Say else if stage is equal to crowd sale stage ICO. Rate is equal to 250. All right. So basically, whenever they're calling this, it's going to update the actual rate for the tokens. So we can just compile this, make sure it works. I know I've been running the tests sometimes, but sometimes I like to just see if it compiles. And while I'm doing that, I'm going to go back to the tests, and let's write some more tests to see that the rate's actually updated. So let's write a first test that just says that the ICO actually starts at the rate we want it to. So it just starts at the opening deployed rate. So basically the rate, crowd sale rate, should equal this dot rate, what we passed in, this dot rate, which is here, 500. So we want it to start there by default. All right, so compilation. Oh, compilation actually failed. Sorry, I made a boo-boo whenever I wrote the Solidity code. Elf. Sorry, guys. I'm sure you see these errors like way before I do. I'm so focused, like talking and writing code at the same time. It's actually pretty hard. My fault. My apologies. At least I can catch my own errors. So let's just run the test. It'll compile while it's doing that. All right, so we're checking to see that it starts at the opening rate. That's the new test here. All right, so that worked. That passed. Let's go back here and check for, let's add some lines to this test. So basically we'll say it allows the admin to update the stage and the rate. So whenever they update this crowd sale stage to ICO stage, then the rate should change. So let's just read the rate and say const rate is equal to await this crowd sale rate, and we'll say rate should be big number equal this ICO rate. So let's actually store that. And here we'll say this dot pre-ICO rate is let's say 500. This dot ICO rate is equals to 50. Let's actually update our test to check for both of those. So we'll say it starts the opening deployed rate. We'll say it starts at the pre-ICO rate. And we'll say this dot pre-ICO rate. Make sure I did that correctly. Where'd it go? Paste that in and say this dot crowd sale rate is equal to ICO rate. All right, so let's run this test. All right, it passes. So the last little bit of functionality I want to add to this smart contract when having presale support is basically saying that whenever we're in the pre-ICO stage that we want all the funds to go to the wallet, and when we're in the ICO stage we want them to go to the refund vault. So I'll do that like this. Basically I'll override if you look at refundable crowd sale, right? Oops, that's the ABI. Refundable crowd sale. If you look at the forward funds function, right? Basically, I'm just going to copy this. It says vault deposit, value, right? So the entire time the crowd sale's open, but with our current crowd sale, it's going to the refund vault because we declared this refundable crowd sale. But what we want to do is actually override this and say, basically, if stage is equal to pre-ICO, right? I'm going to copy this. Just copy this. Stage is equal to pre-ICO. Actually, sorry. Let's copy this entire thing. Sorry, this is looking kind of ugly. Let's back up here. All right. I'm going to copy this conditional out of this function just to get started faster. So if the stage is equal to, current stage is equal to pre-ICO, then we actually want to transfer the wallet, funds to the wallet. Say wallet transfer MSG value. And if not, we want to call super, which is what's being called. This is the line that's executing whenever it gets supered in the refundable crowd sale. And so what I want to do is basically write the notes here, say forwards funds to wallet during the pre-ICO stage and then the refund vault during the ICO stage. All right, and you can see that like in the basic crowd sale, the forward funds function does that, wallet transfer MSG value. So basically we're just saying like if it's in the pre-ICO stage, like do what the regular crowd sale does, but if it's in the actual public phase, then do what the refundable crowd sale does. All right. So now we can write some tests for this behavior, and I'll go to this crowd sale. So what I'll do is go to the refundable crowd sale examples that we wrote in the last video. I'll go to refundable crowd sale, and basically I'll say, I'm just going to paste an example here and say basically, when the crowd sale is in the pre-ICO stage, then it's going, when we buy tokens here, when it does this, then the wallet's going to have its own balance. So like balance of this wallet is going to be more than 100 ether because this account was deployed with 99 ether. And if we contribute some ether to it, it's going to send that over. All right, so we can run that. All right, it passes. So we write one more test, basically to check that when the crowd sale stage is in ICO phase, that it's going to send the funds to the refund vault. So before we run the test, it's going to set the crowd sale stage to the ICO phase from the admin, and then it's going to buy tokens, from investor one for 1 ether, and then we're going to say it forward funds to the refund vault. So we'll say, Web3 ETH get balance of this vault address, which we set in the before each function. Vault address is this crowd sale vault. We're going to, where'd it go? Sorry. We're basically going to say that the balanced number is going to be more than 0. So basically it's going to have some funds. So save that, run this test. It passed. All right, that's it for today, guys. That's how easy it is to add, multi-phase crowd sale with pre-ICO and ICO support. So, yeah, it's going to support these stages. It's going to update the rate whenever the state changes, whenever the rate changes, and it's going to send funds to different locations depending on the crowd sale phase. So hope you liked that video. Be sure to subscribe to the channel to see the next video in the playlist whenever it comes out. And until next time, thanks for watching Dapp University.